Hi and welcome to 6.1 example 1c. Again, we're graphing the solution set for an inequality. So in this case, we're looking at the inequality y plus 2 less than 0. So one thing to note in this case, right, it's less than, so that means the solutions on our line are not actually part of our solution set. So we're going to draw that with a dashed line. And another thing to note is that we have real numbers. So that means we can shade in our solution set, and that is actually what's called a continuous solution. If you were dealing with whole numbers, you would have what's called a discrete solution. Okay, so again, we want to start off by actually graphing the line of y plus 2 equals 0. So looking at this one, we don't really have an x. So we can't really use y equals mx plus b. We can, but it takes a little bit more thinking. So you could think of a table of values, or you could think of intercepts, but all of those are a little bit trickier when it comes to just y plus 2 equals 0. So what you need to remember is that y plus 2 equals 0 is actually the line y equals negative 2, and y equals negative 2 is a horizontal line. Okay, so that's a skill that we've covered back in Math 10, graphing horizontal and vertical lines. So remember that lines that are y equals something are horizontal lines, meaning flat lines, and if they're x equals, they're vertical lines, so straight up and down lines. Okay, so you could think of this in this case of having basically, if it was y equals mx plus b, it would be, right, this whole part is 0, so it has no slope, and the b, right, is still your negative 2. So that means it would have a y-intercept of negative 2. So you could think of it that way. So basically it has a y-intercept of negative 2, and it never rises, and it just has a slope of 0. Okay, so again, we have to go over to our graph, label our axes, x and y. Okay, and then we want to put our scale onto our graph. So again, our scale, all we have is the negative 2. So we can just mark these off as just each box represents 1. Okay. So now we want to graph the line y equals negative 2. So we said that that is a horizontal line at where y equals negative 2. Or if you want, you can go, okay, a y-intercept of negative 2, and then a line across from there. Okay, but before we take our ruler and just draw a line across the page there, remember, this is a this is a dashed line because it's not y plus 2 is, right, it's not less than or equal to, right, it's just less than. So that means things on our line are not solutions. So that's why we'll draw this with a dashed line. So a dashed line looks like that. And so we get a dashed line. Again, in this case, it's real numbers, so we do care about all 4 quadrants, but it's a dashed line because it's just less than. It's not less than or equal to. Okay, so the next thing we need to do is figure out above or below the line. In this case, it's pretty easy for us to recognize which side of this line is the less than side. All right, it should be this below area. Okay, if we're not sure, again, test point. Don't be afraid to use the test point. So we could use the test point 0, 0 again. So we take the test point of 0 and 0. We go to our original equation, which is y plus 2 less than 0. We sub in, well, we don't have any x's, so we sub in the spot of y. The 0 plus 2 is less than 0. Right? Is that true? Is 2 less than 0? No, 2 isn't less than 0. So that means, right, up here where our test point is not our solution. So that means our solution is this area below the line, right? So we could mark that with arrows pointing downward to indicate that that's our solution set. Or, again, right, it'd be better to actually take that and shade in that area. We can shade it in and not just use dots because this is the real number set. Okay, so our solution set to this equation right, is everything below that line.